So, hydro. For those of you that have a stream running through your garden, hydro is the exact opposite to wind. It is the one thing that actually works brilliantly in this country, and we do have an awful lot of water in this country. So a domestic micro-hydro system, such as the one you've seen being lowered into a pit there, if you have more than about 2 meters of head and a flow of more than 8 to 10 litres a second, we can do something reasonably good with it. Hydro needs good head, it needs good flow. If it has that, the payback period can be very good indeed, between 5 and 10 years. The government grant is currently about 20 pence per kilowatt hour. It goes for the next 20 years, and it pays back 24 hours a day, 365 days a year for the next 20 years. The wind doesn't have to be blowing, the stream just has to be flowing. And generally speaking, streams flow better in the winter than in the summer, which is the time when you tend to need the most energy. So whereas wind can be a disaster, this can be very, very, very good. The only problem with this is that the Environment Agency, or what was the National River Authority, hates them because they're worried about flooding, they're worried about people blocking up the streams. But if you happen to live in an old mill stream and a mill house and have a water wheel, it's a complete no-brainer, to use a horrible term. Get on with it immediately, it'll pay back brilliantly, and you'll have free running costs for the rest of your life. Here's one example of one, the picture that was being lowered in there. This is the mill stream, this is the mill house on the left-hand side. This owner now has no running costs at all. With the grants that he received for doing this, his payback period is about 6 years. For the rest of his life, and probably for the next 2 generations of his family, the house will cost absolutely nothing to run in either heating or electricity. We'll come on to ground source heat pumps in a second, but these plates that are going in here on the left-hand side of the picture, they are the collectors for taking heat out of the water to heat the house. So the idea here is the Archimedes screw on the right-hand side generates about 15 kilowatts of electricity per hour, and that is then used to run the lights in the house and the fridge and the cooker and the ground source heat pumps, which then heat the house. And the heat from the ground source heat pumps come from these plate heat exchangers on the left-hand side. That's how it looks when it's finished. Now I know that beauty is in the eye of the beholder, but it's an interesting engineering feat, if nothing else. It doesn't always have to be quite so close to the house.